So moving on to expressions and equations. So it's like in English, math has its own language. Okay? You know how in English you have a phrase and you have a sentence, right? And they're two different things. Same with English. It's the same with math. In math, we have what we call an equation, and we have what we call an expression. And they're two different things. Okay? They might look similar, but they're missing information. They're not the same. Okay? So an equation is like a sentence. It's a full sentence. Capital, period, everything. Okay? With an equation, what we have an equal sign, the left side and a right side. Okay? So you always have that equal there in the middle, somewhere. Doesn't have to be exactly in the middle. Okay? So that's where the word equation comes from the equal sign. Okay? So for example, if I tell you you have 2x plus 1 equals 3, that's an equation because you have that equal sign. Okay? You can solve an equation. So you can solve for the variable. You can find what number can I put in that variable that satisfies the equation. Okay? The equation is like a balance. You have left side, right side, and then you have that balance in between. Okay? With the expression, it's like a phrase. You can't solve an expression. You can just simplify. Simplify means you can collect like terms. That's it. We'll talk more about like terms later. Okay? An expression has no equal sign. Okay? So it only has one side. So let's say if I have 2x plus 1, that's an expression. Okay? You don't have that equal something. All right? So this is the two different terminologies that you're going to hear me say. Expression, equation, okay? And you need to understand what's the difference between the two. Let's read this, and let's try to write either an expression or 10 is 5 less than a number. So if you want to translate this from English to math, how would you translate this? You've got some of the ideas. I don't know where you're getting the minus from. So 10 is 5 less than a number. Do I know what that number is?
10 equals to 5 equals x.
Okay, so 10.
Equals to 5 minus x.
Okay, so 10 is translated into equal to. Okay, so 10 is, that means 10 equals to. 5 less than a number. How would I write that? It's not 5 minus x. What's 5 less than 15? And how did you do that?
15 minus 5 is...
15 minus 5, right? Okay, so 15 minus 5. What's 5 less than 20? How do you write that? 5 less than 20. Okay. What's 5 less than x? No? Why? If you were saying 5 less than 15, and you write it as 15, take away 5, right? 5 less than 20. What's 5 less than, how do you write it? 5 less than 20. 20 minus 5. 5 less than 30.
25.
But what do you write? 5 less than 30.
Minus 5.
So 30 minus 5, right? 5 less than a number, x. So x minus 5. You see? 5 less than 15. 5 less than 20. 5 less than 30. 5 less than x. Okay? So 10 is 5 less than a number. So we're going to say that the number is x because we don't know what that number is. So x minus 5. Okay? So I translated the English sentence, okay, that has a verb and that has a period into an equation. I think the second one is easier. 5 more than a number is 7. X plus 5 equals, so 5 more than a number, right? More means plus. 5 more than a number means equal to 7. We don't do a lot of this, by the way, in grade 11. Okay? But what we're going to do is whatever comes next. Okay? Now, look at the difference between the sentences here. This sentence is a number less than 5. Or this phrase, sorry. A number less than 5. A number less than 5. So you're going to start with 5, and then you're going to take away a number from it. Okay? Now, 5 less than a number. What's your number? X. And then you're taking away 5 from it. Okay? But you see how this is just an expression, right? This is just a phrase. This is not a complete sentence with a verb and a period. Do you guys see that? Do you see the difference? Okay. Now let's see what's the difference. What can I do with this versus what can I do with this? So with this one, I can actually solve for the unknown. Okay? I can actually isolate for that variable by doing what we call opposite operation. Okay? So if I have 10 equals x minus 5 and I want to isolate for the x, what do you do? So you want to leave x here and you want to move everything else to the other side.
So that would be 5 minus x. Right?
Why would it be 5 minus x?
I don't know.
No. So your equal is your balance, right? You want to move things from one side to the other side of the equality, okay? By doing so, when you're moving something from here to here, if you're going to move this from the right side to the left side, you're going to have to perform the opposite operation. So what's opposite of subtraction? Addition. So because I'm going to move that negative 5 over to the other side of the equality, it's going to become 10 plus 5. Okay? Do we understand that? What's 10 plus 5? So that means x equals 15. Does that make sense? Does it make sense if I put 15 here with 15 minus 5 equals to 10? So I solved for that variable. Now this is easy. You probably would have guessed it. You probably would have said right away that x is 15 because what's 15 minus 5? What's equal to 10 if I subtract 5 from, right? But the harder the question or the harder the equation, the harder it is to solve without doing opposite operation. Second equation is x plus 5 equals 7. How would you isolate for x? What do you have to move? So you want to move the 7 over? I want to move the 5 over. Try not to move x unless you really have to. Okay? X can stay here, and you're going to move things away from it. Okay? So, this is with the x. I want to move it to the other side. Okay? So that will be 7 minus 5. Okay? Because I'm moving the 5 over to the other side, it becomes an opposite operation. Opposite of addition is subtraction. What's a 7 minus 5? I'm just going to erase this and write it. Does it make sense that x is equal to 2? 2 plus 5 is 7. My left side is equal to my right side, right? Remember, the equality is a scale, is a balance. Has to be equal. Now, with the expressions, there's no equal sign for me to be able to move things around. Okay? You need that bridge. You need that equal sign to be able to move things around. With the expression, there's no bridge. So I can't move things around. I can't solve. But what I can do is evaluate. So if I come and tell you, let x equal to 7, then I am telling you what the value of x is. So all what you have to do, what you have to do is you have to substitute the value of x in so I'm telling you that let x equals to 7. Okay? So what you're going to do, you're going to take your equation, you're going to replace x with the value that I've given you. Okay? So that's 5 minus 7, which is equal to negative 2. Okay? Can you do the same thing for the second question, for the second expression? So again, x is equal to 7. You're going to substitute x 7. So 7 take away 5. What is that equal to? 2. Okay? So with the expression, you can only evaluate the expression if I give you a value for x or for whatever letter you have. Okay? So here's what I want you to do. I want you to try these two questions. They gave you the value of x, which is 2, and they gave you the value of y, which is 3. All what you have to do is replace the x with the value of 2, replace the y with the 3, and then follow BEDMAS to evaluate. Do you want to do the first one together? Okay.
So it would be 2 times 2 and then
That's right. So 2x plus y. So that's the same thing as 2. What am I replacing x with? 2. So it's going to be 2 times 2. Yeah. Plus, what am I replacing y with? 3. What does BEDMAS say? So 2 times 2 first. What's 2 times 2? 4 plus 3. So that's going to be 7. Okay? Are we okay with that? Okay, I want you to do the other two and try working on the on question number 2. All right? So you're going to do these and this one. Are you okay with that?
what's the team side of x?
This one, it's x squared to the power of 2. Do you all know what power of 2 look like?
That's
The exponent.
the one, right?
That's like on your calculator, you'll either have this, or you'll have this, or the hat. Okay?